Okay, so yesterday we talked about our properties. When you see multiplication, what do? You separate it and we use a addition. Division, we subtraction. What do we do with exponents? Bring them out in front. So if you can do this problem right here, if you can expand this one problem, I feel like there's nothing I can give you that should cause you any trouble. So this would be, first thing would be log base 2 of 8. So we give the 8 its own log, right? It's times a to the third, so what should come next? Plus. And then we'd have log base 2 of a to the third, but what do we do with that little 3? What do we do with the exponent? That, instead of writing it as the exponent, we bring that out front, and we just put that right there. What would come next? Plus 5 log base 2 of b, and then it's division now. So now it's minus 2 log base 2 of c. And a lot of people get confused with this one here where it does look like c times d kind of thing. But basically, we're dividing by the c's. We're also dividing by the d's. So anything in the numerator should be positive. Anything in the denominator should be negative. So what should come next? Minus. Now, this is the third root of d. What really is the exponent here? 1/3, right? So what should come next? 1/3 log base 2 of d. It is really long. I made one really long. Do you think the ones on your test and quiz are going to be this long? No. They're really not. They're really, really not going to be this long. I look at, especially when I'm doing them on the board for you, typically speaking, I want to do the hard ones. I want to show you the hardest ones. If you can do this, the rest should be easy for you. Okay? There's one on the test or quiz. I can't remember if it's coming up on the next quiz or it's on the test, one or the other. There's one that looks like this. I want to say it's x squared over y to the third. Something like this. And everybody gets it wrong. I don't know why. It's not even that hard of a question. What should come first? What do you think?
2 log base 3 to the third.
Of 3, right? Okay.
Plus
Plus
2 log base 3 to x.
Now, why did you put a 2 in front of both of those? They're both raised to the second power up here, aren't they? Well, that means you have to have the 2 in front of both. Would it be allowed, and then what would come next? Minus 3 log base 3 of y, right? Would it be allowed to write 2 times the quantity of log base 3 of 3 plus log base 3 of x? Is this allowable, do you think? Where I could just pull the 2 out in front right now, and then it's plus, separate them. Is this the same thing as that? Yeah, I mean, I'd still have to distribute that too. That's fine. I mean, yes, I would need the rest of it. Either one of those is perfectly fine. Now, if I wanted to go a little step farther, what is log base 3 of 3? 3 to what power equals 3? This whole logarithm is just 1. So actually a better answer would be 2 times 1 would just be 2 plus 2 log base 3 of x, and so on and so on. Make sense? I could have done the same thing on the previous one right here, because I can simplify that. 2 to what power is equal to 8? So that's the same thing as 3 plus 3 log base 2 of a plus and so on. Make sense? What's that?
Now you're confused.
Now I'm confusing you? By simplifying? That should be an easy thing. Sorry. Because that's all it is. Whenever you see a log, just remember, that's all you have to think. Take the base. All this is saying is 2 to what power is equal to 8? Well, I know that answer. The answer is 3. This whole thing just simplifies to 3. Yes, Derek? I got it? Yes.
So on our quizzes, do you want us to simplify like that?
See, here's the thing. Here's where you guys get lucky. If you write this, do you think I'm going to give you full credit? I am. If you write this with all the rest, do you think I'm going to give you full credit? Yeah. For this problem, if you write this, you think I'm going to give you full credit? Yeah. If you write this, you think I'm going to give it to you? Yeah. If you write this, I'm damn good at these. I really am. I am really good at this stuff, which is your benefit because you write this, you write this, you write this. It's okay to have different answers. Throughout the year, there's going to be times where you have a slightly different answer than he does, or vice versa, and you have a slightly different answer to both of them. That's okay, because I know there's multiple answers, and I would like you to get all to the same answer, but it's okay if I'm more concerned right now with, are you understanding how we expand these? Do you understand the properties? Would I like you to simplify the absolute best? Yes. Which answer of these three is probably the absolute best answer? The bottom one, right? If you don't quite get all the way there, okay. Now, I do have to take points away because I see this a lot though. If I see, let's go back to this. Okay. This problem right here. For whatever reason, I see people do this all the time. They go, well, that's the same thing as log base 2 of, I'll put the 3 out in front, and I'll put 8a plus 5 log base 2 of b minus. What's wrong with this?
The 8a, the a is included.
Yeah, like I should have a different log for the 8 and then a different one for the a, right? Separate those. Plus, this actually isn't even the same. Because if I put that rule back in place where I move that exponent, shouldn't both the 8 and the a be raised to a third power? So this isn't even technically mathematically correct. If you do stuff like this and you don't actually separate them, even base 4 of 2x y to the third, and that's all you have. And you write log base 4 of 2x plus 3 log base 4 of y. Is that technically a correct answer?
I guess not.
Yeah, it really is. It is technically correct. It's not mathematically wrong. But to me, doing something like that is the equivalent of saying, reduce that fraction. Okay. I did. What did I do? I didn't really simplify it all the way down, right? So I'm not simplifying it all the way down. Some people would argue, well, aren't I doing the same thing to this problem if I write this and I don't simplify this all the way down to that? Yeah, but, you know, right now I'm testing you on can you expand and condense. I'm not necessarily testing you on can you simplify those. I am going to test you on that part on the next question though, because there is going to be one right below it or above it that says, what does log base 2 of 8 simplify to? Hopefully you see it. If not, I'll survive. Make sense? On the test quizzes, there's going to be two types of questions. There's going to be take this one logarithm and expand it. The very next question is, I'm going to give you this and say condense it down into one logarithm. So we have to be able to go in both directions. Does that make sense? What's that? Yes, you could. You're a pretty smart guy. Everybody take a look at page 351. 351. I want you to jump all the way down to number 48. It says log base b of 2x squared y squared over the 5th root of z. Ready, set, go. This is where you at home should be trying it too. Then got an answer? What do you got? Log base b of, okay, plus 2, okay, plus 2, log base b of y, okay, minus, I would just write it as a fraction. I mean, you could write 0.2, it is correct, but I'd say 1/5. Log base b of z. Fractions make life easy. Just leave it as a fraction. Don't even worry about a decimal. Okay? Easy? Switching up the numbers, just not a big deal? Okay. But I want you now to go back to number 24. And number 24 says 3 log base n of 4x minus the quantity of log base n of 5y plus log base n of 6z. And I want you to condense that down into one logarithm. So how many times are you going to write log? One time. Log base n of. Everything is going to go inside that n, or inside the of. Got an answer? What do you got? What? Don't have some confidence in yourself.
So I have 4x.
4x. To the, like this?
Yep.
Okay.
And then
5y and
6z.
like that. There's two things I don't like about that. One, the denominator can be simplified. What would be better to write for the denominator? Can you do anything with the 5 and the 6? All that says is 5 times y times 6 times z. Is that the same thing as 30yz? Then yeah, just write that as 30yz. That's easier. But there's actually something mathematically incorrect about this. Yeah, does the 4 also need to get raised to the third power here? Is the 3 out in front of the 4? Yes, it's also out in front of the x. That means you either have to write it like that, where you have parentheses over those, or you could have written it like that, where both of them are raised to the third power, or you could just figure out what 4 to the third power is. The best, the absolute best answer to this would be log base n of. What's the only thing I did there? Reduce the fraction. Out of the 3 other ones, I would prefer this, personally. But if you wrote any of the other 2, where you had the 4 to the third or 4x quantity to the third, I'd be happy with any of those. Okay. The easiest, I would say the 4x to the third would be the easiest to me, because it's using the least amount of properties, but whatever, floats your boat. Are we good with these? Okay, now we get to do my favorite types of problems. Okay? These are my favorite ones. These are my favorite ones to teach. And you're going to find this year that once in a while, I kind of create my own math rules. You're never going to find some of the rules in a math textbook for obvious reasons. But I've been teaching this stuff for long enough to where I've found some tricks that I think help students remember stuff, right? So, you got a problem like this. The goal is, you got to solve for x, right? All right, so you have a problem like this. It says log base 10 of this is supposed to equal log base 10 of that. If log of this equals log of that, what has to be true about this and that? Yeah, just drop your logs. And go. Now, dropping your logs is typically, something you want to do in private. But here in math class, you can drop your logs anytime you want, as long as you have a log on both sides. You guys are boring. How can you not giggle at dropping your logs? Like, everybody laughs at poop jokes.
At both sides.
Heck with you guys. I ain't even going to try anymore. Yeah. So drop your logs. When can you drop your logs? If they're the same log on both sides. Okay? We just drop those logs. And then I would add the 25 the other side. So you get x squared equals 169. And then how do you get rid of that square? What's the square root of 169?
13.
Okay. What's the square root of 169?
13. Plus or minus 13.
There you go. Now, that's important. That is absolutely important to remember that plus or minus, because our job is not just to find any answer that will satisfy this problem. Our answer is to find every answer that will satisfy this problem. Now, there is a problem here. Have you guys ever heard of what are known as extraneous solutions? All right, so let me give you an example that'll help you define the word extraneous. Okay? Take Derek, for example. Derek is probably what we would consider an extraneous athlete. Okay? Now, what an extraneous solution is a solution that looks like a solution, acts like a solution, sounds like a solution, but solution.
Hold on. Wait. Go back to this
Now, we have to check our answers. We really do. Because there's a major problem with logarithms. We said when we graphed logarithms, the graphs look like this, right? We also said the domain is what? What types of numbers are we only allowed to take the log of? What? Greater than 0. We cannot take the log of a negative number. It is impossible to take the log of a negative number. That will not work. It will never work. So, what we have to do is anytime we get solutions, we have to plug them back in. I'm not saying we throw out all the negatives. Sometimes we will. Sometimes we'll throw out the positive. In this case, if I go 13 squared, 169, minus 25, that's a positive number. If I throw a negative 13 in here, does that negative in this case make a difference? No, because as soon as I square it, it turns it to a positive. So I'm actually not, even though I'm plugging a negative 13 in, I wouldn't actually be taking the log of a negative number. Does that make sense? So I have to kind of calculate it before I determine what. So in this case, both of those answers work. Say that one more time.
What if x equals 3 and we're subtracting 25?
Yeah, so let's say you solve this down and x equals 3, a positive number. When I plug that in there and I go 3 squared is 9, 9 minus 25, that's going to be a negative number. That would be then an extraneous solution that you'd have to throw out. It would, like maybe it factored down into it and you got 3 as a solution. That would be what's considered an extraneous solution. You'd have to then throw it back out. Make sense? Yes. Whatever the other one is. So you'll always have 2 generally. And then one of the answers will work, one of them may not. For example, I want you to look at question... Let's do 55. The next page. It says log base 5 of 4x plus log base 5 of x is supposed to equal log base 5 of 100. Now, I have logs on both sides. In this case, can I drop my logs right now? No. Because I don't have log of this equals log of that. I have multiple logs on this side, don't I? Do I have a property that I could use to turn this into a single logarithm? What's my rule? What do I do with 4x and my x? Multiply. What is 4x times x? 4x squared. So the first thing I do is I use a property. Turn that into a single logarithm. Now, I have log of this equals log of that. I can drop your logs. It's a lot more fun if you say it. Okay? Good so far? So I get down to here. 4x squared equals 100. What's next? Divide by 4. I get x squared equals 25. I take the square root. What's the square root of 25? Plus and minus 5. Okay? Got to remember that. Because sometimes, last problem, didn't both answers work? Now in this case, if I plug in a 5 here, am I allowed to take the log base 5 of 5? Yes. If I plug in a negative 5 in here, is it going to cause a problem? Yes. In this case, negative 5 is not a solution. X equals 5 is the and only solution. In this case, if you wrote plus and minus 5, I'd have to take a point off because you gave me a solution that does not work. What? Because sometimes the plus and minus, the last problem, when I just took the square root of 169, I got plus and minus 13. Did both of them work? Yes, so I have to, if I don't put plus and minus 13 on this problem, I got to take points off because you didn't give me every solution that works. When you take the square root here, I get plus and minus 5. I got positive 5 as a solution. I got negative 5 as a solution. But negative 5 is an extraneous solution. It looked like a solution. It acted like a solution. It looks like we need to keep it. But when we check our answer, put it back in the problem, it causes a problem. It actually is not a solution. It's kind of like that kid that goes to practice and, oh, he's a practice player. He does great in practice. It looks good. I put him in the game and, oh, he sucks. Yes.
So you have to do it to the first one, not like when you simplify it?
Yes, you go back up here. Yeah, don't look at this one. This is just a simplified version. It has to go back into the original.
So you're just taking, so you start off and you put plus 5 in for the x.
See if it works. Then chuck the negative 5.
So what do you mean if it works? Like that's a dumb question, but
Because the only thing you really have to be worried about is, are you going to take the log of a negative number? When I plug in log base 5 of 4, and I plug in the negative 5 plus log, is this allowable?
no.
No, that's going to be a negative 20 in there, isn't there?
Oh, so if you get
Not allowed. Anytime you get log of a negative. Now, this exact same question, let me just change the question just a little bit. Let's say instead of that, I put negative x in there, and I put a negative 4. Would that have changed this step? No. When I multiply them, don't I get positive 4x squared again? And then I get the exact same problem. I got positive 5 and negative 5.
that'll work.
Only the negative would work in this case. Because now, when I plug the negative 5 in, when I plug the negative 5 in, it turns it to a positive 5, right? So now, again, both of them don't work, but the positive one would be the one I'd have to throw out. I'd want to keep the negative as my only solution.
So if that x in parentheses was positive, would be equal?
No, because I can't plug a negative in here. You can't take the log base 5 of any negative number. It's not that I'm plugging in a negative number. It's, let's say it was log base 5 of negative 2x. Let's just say it said that. If I plug in a negative 5 in there, would I actually be taking the log of a negative number? No, I'd be taking the log of, so that'd be a fine solution, right? But if I plugged in a positive 5, not a negative 5, would I be then taking the log of a negative number? Yes, I'd have to throw it out. So you got to plug it in, figure out what that would be. If it's positive, it's generally okay. If it's negative, gone. Good? How would you do a question like 63? So it says log base 7 of x minus 5 plus log base 7 of x plus 1 is supposed to equal 1. What do you think I should do first? 2 logarithms, I should make them 1 logarithm, which would mean, what do I have to do with the x minus 5 and the x plus 1? I have to multiply. I have to FOIL, which would be x squared. I'd have a negative 5x, a positive 1x would make negative 4x, negative 5, right? In this case, can I just drop my logs? No. I can't just drop my logs. I don't have a log on both sides. I need some other method to do this. When you get stuck, what did I say was the trick? Switch forms. What is this log equation in exponential form? 7? No, 7 to the first power is supposed to equal that x squared minus 4x minus 5. Well, that's just a quadratic. How do you solve quadratics? You get everything on one side. That's a 0. That's just 7. X squared minus 4x minus that 7 over there. You'd have what? Negative 12? Factor it. What two numbers subtract the 12? Or multiply to negative 12, subtract the 4. 6 and 2. What? Negative 6, positive. So I get two answers, right? 6 and negative 2. Am I done? No. I have to check those both for extraneous solutions. Can I plug in a 6? 6 minus 5? That's fine, isn't it? 6 plus 1? That's fine. 6 is going to work. How about my negative 2? Why not? So, what if I got an answer of 3, positive 3? No, because that would then be a negative. Does that make sense?
And what do you do?
So in this case, at the bottom, solution I need. Make sense? Good with these?